Hello. Uh, this is my talk, Building a Complex Application While Maintaining High Quality, which sounded like a good title at the time, but I think it's kind of long and sounds a bit bullshitty, so we'll try to explain it a little bit better than that. Especially because it's a bit misleading, because I won't actually tell you how to build a complex application while maintaining high quality. I'll just tell you how we did it, because what we did doesn't necessarily mean that it will work for you. So, who actually am I? My name is Michael England, and I'm a core iOS engineer at Soundcloud. I should also say this is my first ever conference talk, so go easy on me and give me some feedback later on. So, how did I get here? I used to be an Android engineer. I did that for about a year and a half full-time. Then I switched to doing Android and Ruby backend in parallel. Before moving to Berlin, and then I was a full-time Ruby backend engineer for about a year and a half, and then I joined SoundCloud. I joined SoundCloud as an Android engineer, got it on my contract and everything, and immediately joined the iOS team and never worked on Android ever since. But that was more due to the needs of the team and whatnot. So the reason why I tell you this is because this is why I think the learnings are more like learnings I've had in general of working on mobile throughout the last few years, as opposed to just like one platform. So what am I actually going to talk about today? I'd like to talk a bit about the Soundcloud Ios app, the brand new app, specifically the last 2.5 years experience I've had working through it. In that time, we've rewritten the entire application in 9 months with 5 engineers, I think it was. And we've changed the entire organizational structure and doubled the number of engineers on the team. So I'd like to go into a bit more detail about the rewrite project by highlighting some of the general things that happened along the way, how we've changed since then, and my learnings. So let's talk about the actual rewrite. So this was SoundCloud as of early June 2014. It supported iOS 3, which is 6 years ago, so it's quite a lot of support. And there's a lot of things going on there. Like I think that player alone has maybe 10 or 11 calls to action, and it's not very clear to me what I'm supposed to do when I open the player. This is the SoundCloud app as of late June 2014. So it supports iOS 7 and above. It's a completely new design and entirely new code base. As you can see, it's a bit more modern. It's the flat design, and we've got a lot of iOS 7 specific things that came in, like parallax and other such things. So why did we do a rewrite? Because I don't know if you've ever read any of the books like the Clean Code book, where it pretty much starts by saying never ever do a rewrite. It's a terrible idea. Don't ever do it. Well, we also thought the same thing. So we took our old code base when we got hired, because this was around about the time that the team was hired. We tried to build the first feature as a team or whatnot, which was an onboarding feature, where a bit like Twitter used to do, where you sign up. When you first sign up, you get offered a load of different users that you might want to follow. And this feature took 3 months, I think it was, to build, which was way too long. So we decided we needed to build the application again. We needed to be able to get faster velocity. We needed to have a more flexible code base that allowed us to do lots of different things. We wanted to focus on high quality as much as anything, because we want to be proud of the application. And we wanted to go back from the design point of view to the core functionality of the app. But we definitely are aware that it was a huge risk, especially because it was a greenfield project with new developers. So when I say focus on quality, the reason why is we inherited the code base from a consultancy. The old app itself had huge quality problems, where we even had some bugs that had I think we got about 10,000 a day or so of just bugs that we could not fix with the architecture. We also had a motivation to use cutting-edge architecture, which is sometimes a good thing, sometimes a bad thing, right? And also we had this old school thing of submodules of submodules of submodules of submodules, and it used to take us, I don't know, 30, 40 minutes just to get the app set up on your laptop. So the old app had a crash rate of about 3.8% per session. To put that into some perspective, I saw an article on Criticism where they have a nice graph of all the different average crash rates. Criticism is one of these crash recording tools, and the average is somewhere between 2.5% and 3%, so that's pretty high. We wrote the application entirely from scratch, all of the code over 9 months, and we released a new application, a bit risky, right? And we released it with 0.1% crash rate. So we see that as quite an achievement for, given how many lines of code we're going in, having never been in the hands of all of the real users before. Especially because we had asserts turned on, which meant we would purposely crash the app if we found anything go wrong during the process. And 70% of all of the listening time at SoundCloud goes through our mobile applications. So it's quite important to the business. This is I really thank the community team for doing this graph for us, but this is the number of complaints that they used to get per week about crashes, and there's another one with the bug reports, and you can see that definitely took a bit of the time out of their week for that. Yeah. So let's talk about how we actually started doing this thing and the decisions we made along the way. So I say sprint 0 and 1, because this is like I don't know if it's Scrum specific or an Agile thing, but you always talk about the sort of infrastructure and the work you have to do right at the beginning of a project so that you can get started and then move forwards. So the first thing we did is we went to a colleague's flat, Vincent, and we did an estimation session using Post-its on the board. So we took this massive scope project, split it up into as many stories as we could, and then we just stuck them on the wall in terms of priority, tried to arrange them by scale, did some guesses as to how many we could get done, tried to put them at some sort of estimates of story points. This isn't actually the picture from the flat. I could not find a picture from the flat, so I shamelessly stole that pretty cool looking slide from the UK government, which I'm quite surprised that they do estimation sessions, but there you go. So what decisions did we make? We decided to leverage as much of the Apple platform as we could. So although, well, I'm not sure this is totally true for the whole team, but I certainly regretted the decision to go with Core Data, but at the time, these kind of decisions were the right ones because we wanted to not reinvent the wheel as much as possible. And so we used storyboards and other things like this. We wanted to go with a functional reactive approach, which on iOS is Reactive Cocoa, but on Android we do it with RxJava, and on the back end there's Akka Streams and all sorts of other tools like that. So it was a bit more in line with the way that we were building things elsewhere in the company. We also decided that we would build our own API. So we have the idea at SoundCloud that every application or platform could benefit from having its very own API layer because we have microservices hiding behind everything. So we decided that we would build the endpoints that we needed in a special API for the time. We went with the smallest scope possible, but that one's more for the product managers to talk about. And we chose Scrum. So we chose Scrum because most of the rest of the business was going with it. We were quite a young team in the sense of we didn't really know each other that well when we started doing it. We were quite fresh. And it's a pretty sort of standard structure to get you started. We also had a prototyper who would build throwaway apps, native applications that we could use and do user tests on. And then they're also great as a developer for a spec when you have a working application to build your working application from. And we also wanted to do early feedback cycles because what we didn't want to do is get feedback from people after 9 months because it's way too late. So we tried to do the alpha and beta and so approach. So this was our first feature that we built, which was Explore. We decided that because it's pretty basic. It's kind of a standard way that the rest of the application is as well. It's a list, which is what most of the app is. And also, it was a nice app to get started with because it's anonymous usage. And we went with anonymous usage because we used to have about a 50% drop-off when we were forcing people to sign up when they came to the app. So we focused heavily on testing in this early stage for building the infrastructure. So we did a lot of unit testing and getting that set up. So dependency injection. The libraries that I've put there are iOS specific, but it's just the BDD style, the behavioral driven testing. And we also did acceptance tests with a tool called Frank, which is Frank Cucumber, which is a thing you don't generally put on a slide. Frank Cucumber, but anyway. It's actually a tool that allows us to use some simple English-style text, and then that in turn gets turned into button presses on the application where we could determine if the app was behaving correctly. We manually tested anything else that was left. So, for example, Facebook sharing, we just couldn't test that with automation tests, not yet at least, so we decided to manually test everything. And we also decided that reachability would be important. So reachability is an iOS-specific phrase, I think, but it's more like connectivity. So we said users with poor network is not an edge case. It's actually a very common case that users have a very poor network. So this needs to be a first-class feature when you're working with it. And we also did some performance tests. So we did a lot of using an iPhone 4 and trying to see that the scrolling was all good and making sure everything was okay. We built a lot of tooling, so we went with the idea that if a tool didn't exist that we needed, then we had to build it. We didn't just ignore it or say, that's not possible, we just built it. Nowadays, there's a couple of CI tools that seem to be coming out, like I believe there's Bazel by Google and Book by Facebook, and then there's Fastlane now and a couple of other things, but we built an entire CI pipeline in Ruby because we needed to do it. And the pipeline has things like linting the code, running the unit tests, running the acceptance tests, deploying the binaries to Hockey so that our users could immediately have alphas and betas, and also creating a releasable IPA that we could upload directly to the App Store because we never wanted to do manual deploys. We used Fabric, which was Crashlytics back then, to do all of our crash logging. Shameless plug for Factory Gentleman and Core Factory Gentleman. So we needed a tool a bit like Factory Girl from ThoughtBot, where we could create real core data objects for use in our unit tests, but we didn't want to spend most of our code building this in the tests, so we created some blueprints and we created a library to be able to do that. We used GitHub issues, so whenever there was any problems or bugs or anything, we just dumped it straight into GitHub, and then we would triage it pretty much immediately, so the next day we would try to fix it. So if there was a bug during a sprint on a feature we were working on in the sprint, we would fix it immediately. If it was something that we found from later on, then we would add it to this document and then try to fix it in the morning. And we used Jira because the company was on Jira, mostly. So lists are hard, actually. Anybody who's built lists on iOS or on Android, it sounds kind of like a simple thing, but building lists that can handle all the different states is a bit of a nightmare, and you usually end up with some giant list activity on Android or a list view controller, collection view controller subclass. Because what do you do if the app is paginating, has an error, is currently not reachable, the screen is empty? And we actually had specific product requirements for each of these. Like, if the app was not reachable but you already had content on the screen, then we wanted to just leave you with the content that was on the screen. But if you didn't have any content, we didn't want to show a spinner, we wanted to show you a proper screen that says that you're not reachable and things like this. So due to the complexity of all the potential states, we had to test and test and test. And we would found that within 3 to 4 days, we would have regressions on the states that we'd previously fixed. So we built a pretty conclusive test suite around everything, and we even built a reachability faking system that one of my genius colleagues came up with, so that we could send signals to the simulator to tell it if it was reachable or not. And this solved the problems. Like, we went from wondering if we would ever finish the feature requirements to been able to prove that they were all working, and ever since then it's been fine. So then we moved on to the player. So we picked the player because it's totally different to the rest of the app. It's the core functionality of the application, and a lot of risk is in the player, because if there's a bug with the player, users are very unhappy. If there's a bug with search or stream or likes or some other thing, then it's not as bad as with the player. Around about this time, we actually grew the team. So we hired 2 people, and that was quite a learning curve for me, certainly, because we did a lot of hiring at the time, and it really takes a lot of time out of your day, and the onboarding as well. So we tried to hire for complementary skill sets, because we've been burned in the past by hiring only specialists or only generalists, and the good thing is to try and pick a combination of both of those so that you get complementary skill sets. So the player itself, the player is very complex. It's the core feature of the app, as I mentioned. It doesn't maybe look that complex because the designers did a good job, but it's wrapping around AV player. There's all sorts of things that can go wrong. There's action sheets that pop up, and then what if the track finishes while the action sheet is up? Do you close the action sheet? It's modal as well, so we had a number of issues. Again, the testing was key. We focused on the performance a lot and the smooth scrubbing and scrolling. It actually took a bit longer than expected, but we decided to still try to focus on it, because what we didn't want to do is put off the potential bugs or issues to the end of the project and say it's better to keep working on the other features, because we knew we would end up coming back at the end of the project and then madly dashing around trying to fix such a core part of the application. And the big decision that we made while we were building the player was to fail fast. So this is something very common on the back end, I think, but not so much on mobile. So defensive coding leads to a lot of pain. If you start saying, okay, if I get into this weird situation that should in theory never happen but maybe does, then do this kind of early fail out. But if you do that, you'll end up with bugs that you can never track down. You would just end up in side effects of side effects of side effects. And so we turned on asserts. We started crashing the application as soon as we would get into a state that was not a possible state. This is especially painful on iOS because we have this double-edged sword of the nil, which will very happily continue to work for you even if everything has actually gone wrong. So we decided to sort of work past that by asserting. We made sure we had a proper logger because, especially with the functional approach with the reactive Cocoa, if you've ever tried debugging anything that's asynchronous, that jumps between threads all the time, it's really a pain because you can't actually tell what things caused what. Again, Fabric was very important for the crashing, and we did a lot of internal alphas. So what we actually tried to do is every single time that commit went to master, and we worked off top of master, if the build was green, so if the linter, the unit tests, acceptance tests were all green, we would instantly deploy it to the alpha, and all of the internal users would immediately get an update. So then we started working on all of the rest of the app. So by this point, we actually improved the velocity a lot. Because we did the high risk at the beginning and we built the team by that point, people had started to learn strengths and weaknesses of each other, and the velocity improved a lot. So that is kind of hard to read from that, but it did basically double. We were able to get twice as much work done over a period of about 6 weeks. We went from a kind of slow team to a fast team. And we even added some scope to the MVP before we finished the project because we actually gained so much velocity by the end. Yeah, so again, the demos were incredibly important from the business perspective as well as for us. So, so SoundCloud, every 2 weeks, we do demos to the business. So anybody can come and do a demo, and anybody can listen to the demos. And this is really important for us because we want to keep the business excited, and especially because as far as the business was concerned, the rest of the teams, it's like, okay, the iOS developers have gone into a cupboard for 9 months and haven't released anything, so what the hell is going on? So we wanted to try and keep the business excited by showing them the new features, getting them involved, and also it helps us keep focus. So with using a tool like an agile methodology like Scrum, it's all based on this idea of delivering something after 2 weeks. And if you aren't releasing to the App Store for 9 months, it's kind of anticlimactic to finish the sprint. So we wanted to do this, and we treated this like an actual release. So every 2 weeks was like our release to the App Store. We also improved a lot of our processes at that point as we began to become more autonomous. So we noticed we had this weird inconsistent velocity every single time. So if I even go back, is that possible? No, that one. So you notice how it is going up, but it's actually going up, down, up, down, up, down, up, down. That was because we would get towards the end of the sprint, and then we would have to make a decision. Okay, do we stop now and help the team that hasn't quite finished yet, or do we pick up a new task and start working on it? And it made more sense for the project to keep picking up tasks, but not for sprint, not for the concept of the sprint. So at this point, we decided, okay, it doesn't really matter that we're technically using Scrum. We'll go to a more Kanban style where we just keep picking up the tasks as they come in, but we'll try to stick with the 2-week summaries where we keep sending emails to the other teams saying where we are. We'll keep doing the demos every 2 weeks and still think of it like a 2-week deliverable. We also did something, we call it pragmatic pairing. There's probably some papers written about it by people who know more about it than me. So what I mean by this is we made a decision when we started the project that we would pair on everything. So we wanted to make pairing the rule rather than the exception, because in most businesses, everybody seems familiar with the idea of pair programming. They seem to think that it's really good, but they say, okay, I'll pair on something when it makes sense, and then you end up never pairing. It's the exception rather than the rule. So we wanted to go with this idea that every task requires a pair, whereas sometimes you might not necessarily need to do that. So we split into always sitting together on a story, but maybe if it was extremely obvious exactly what it is that you needed to do and you really didn't need to actually pair on it, then you could still split the task up into mini tasks and work on them while sat next to each other. And this also helped us, but this would happen maybe 10% of the time versus the other 90% where we would pair on everything. We also did trunk-based development, so we wanted to make sure the tests were trusted. And the best way to make your master trusted is to always work on top of master and enforce people to trust the tests. And also we switched to doing dev QA at this point. So we actually had a tester. He's sat there and he's probably trying to hide. Yeah, he is. There he is. So we had a test engineer who worked with the mobile teams who can find any bug in anything. I challenge you to get him to find a bug in your application. But he became a huge bottleneck for the teams. So we would have 10, 20 engineers committing code, and then he just couldn't get through this list fast enough. So what we decided is we would pair with our QA engineer and learn from him on how to do the testing and how to do exploratory testing properly. So that's what we did. And as I mentioned earlier, we decided to build our own mobile API at this point. There's been quite a lot of talks given by my other colleagues on this, but the general idea is we have microservices in the background, and then we have applications, like platform-specific APIs built on top. And a good example of this is our collection screen and our profile screen. So if we'd have used the web API for the profile screen, we'd have had to make 6 to 7 calls to the API. And we decided that this was not okay from a battery and a data usage perspective. So we got some other developers from the other backend teams to come in and pair with us on building the Scala backend, which already had a few things from a previous Android project, but we decided to work together with them. And this was really, really useful for us on learning about the backend, as well as the people from the backend learning about the mobile apps. So then we actually came to the release itself. So this actually is not a stolen image. This is a genuine image. This is our board on the last sprint that we did. You can see we've had some manual testers. We even brought in some manual testers to help us. And you can see all the bugs there, the pink ones, the final ones being built, being fixed. And then we all got together in the cafe in our office, and there was, I don't know, 150 people in there, all ready to press the button. Had a big event to try and make it all about the company getting behind it. And then, I don't know if you've ever done an iOS release, but it's probably the most anticlimactic thing you can ever do, because you've already pushed the binary and then you need to set it ready for sale, and you just press a button and then it's done. It just works. So for us, we pressed the button, and from an engineering standpoint, nothing happened. Absolutely nothing. The product team and the marketing team, a lot of things happened. There was a lot of debate whether it was good or bad, what kind of changes. But from the engineering standpoint, it was it was actually a very boring release, because we didn't do any maintenance fixes. We didn't have to stay up at night worrying about crashes. We didn't do anything. But actually, that's great. I want boring releases. I want them all the time, because yeah, I mean, I've still got some hair left and I'd like to keep it, really. So what do we do after the release to try and keep the crash rate at 0.1%, keep the bugs low, to keep the high quality? Well, one thing that you have to do after you've released your application, if you want to keep working on it, especially if you're working with multiple people, is you need to be able to ship code that is not turned on. So we also have a feature flag system, which is called Flip the Switch, which is open source. And it's really just like this. We just have behavioral checks where we just say, if this feature is enabled, use the new way of doing things. If it's not, then don't. From this, it's also got this ability in the alpha to turn on and off features for testing. And we always keep the alpha ready as exactly like it would be for the next release. So the next thing that happened to the company after we'd been doing this for maybe 6 to 7 months afterwards was we did an organizational change in the whole company. So we switched to feature team model, which there's been some great talks as well by Kevin as well earlier this morning. So we transitioned a single iOS team into multiple feature teams. Now, we don't have the, what was it, 100 teams and 600 devs, I think it was. Yeah, we have 10, actually. So we decided to keep a core team and move into several feature teams. So the idea was to do this. So we wanted to try and keep pairing, keep trunk-based development to enforce the quality of the code base and everything. But actually, that's the theory. What actually happens is that there are more teams than there are people. And you end up doing this. And occasionally, feature team priorities change due to external forces. So what actually happens is people end up moving between teams as well. Which drives us totally crazy on the core team. But yeah, and we're hiring, by the way, in order to fill up the gaps. So this is our current challenge in a way. Like, we have a few ideas on ways to mitigate the problems that you get with this, but that's where we're up to. So one thing we've been doing is crash and bug fixing days. So once a month, we bring all of the iOS developers or all the Android developers together in one room to do an offsite. And we make a team event afterwards, and we sit down and go through and triage all of the bugs. The bigger ones become Jira stories and get put into somebody's backlog, maybe the core team, maybe the other teams. It depends upon people's workload at the time. So what we actually needed to do was, in order to support the feature teams, we needed to decouple our model. So we had a giant model where all routes led to our data model, our core data model. And this does not scale for feature teams. You cannot have this kind of bottleneck for everybody. But I won't actually go into that because Slavko just did a talk on it. So We also decided to do modularization of the app. So it's a bit analogous to the microservices and libraries architectures you get on the back end. I mean, mobile is basically just back end, but 20 years behind. It's the obligatory Conway's Law reference where we say, if we've got this organizational structure of each teams, we should also have the code base and the actual design of the whole business fits the architecture of your apps as well. This also leads to some build improvements because we can do things like only run the search tests when the actual search logic changes and things like this. It enforces decoupling, which is a really good thing. And also it allows us to make decisions on, for example, app splitting. Like maybe we decide that we want to make the player some SDK for other developers to use internally. Maybe we decide that we want a creator app instead of just one app with both. We can make these decisions and it's a bit more like plug and play. And the test engineering team is actually working on a test runner. So one thing we found is that the developers need to use infrastructure from different places because we have different tests. The way that you test things on Android is completely different to iOS and things like this. But the actual overall concepts needed to be shared, needed to be the same. And we had the same problem on both platforms, where if you had a broken build, it would slow down development. But the broken builds sometimes would be, we would have like one test that would fail one time in 15,000 runs or something. And breaking the build for that is kind of painful. So we wanted to have a way of creating a state machine for the tests. I should say this is our acceptance test. This is our high-level tests that test the business value, not the unit tests. If the unit tests fail, you always fail the build. But we did this state machine where we could do things like if somebody's created a brand new business value test, then we run it 10 times in a row to make sure it's okay, and then it becomes a valid test that goes into all the runs. Maybe you retry a test once or twice. If it fails, maybe you don't. Maybe you flag it as flaky, but don't fail the build, and then you can tell the team who's responsible for it or take it out of the build. This is something that the test engineering team are working on right now to help us. So that's actually the current state of things at SoundCloud from the mobile perspective. This is just from my perspective. And I wanted to say a bit about my takeaways from the last 2.5 years of working in this way. So the first thing is building a team is really hard. It takes a long time to get people to know each other's strengths and weaknesses. And you need to make sure that when you build a team, not to keep on changing the teams. Because we noticed that when we had these each team members jumping between the teams a lot, it meant that they had no context on what they were working on, which is very difficult. But you get some huge rewards from that. And the enthusiasm and passion of a good team will get you a lot of things more than you expected. Own everything. Don't just say, that's a back-end bug, or that's somebody else's bug, some other team. Really chase it down, because there's somebody else there. You can also build anything if you want to. You can go down to any level, and I advise you to build whatever you need when you're doing it. Fail fast and hard always. It doesn't matter if it's mobile. The back-end community used to get afraid, so they would have these, I remember companies where you'd have like every 2 months you'd do some deploy and there'd be some guy sweating trying to send out a deploy hoping everything didn't break. And then people would drag themselves to longer and longer releases where they would be more and more afraid. The answer to that, as it turned out, was to release more often, not less often. So nowadays, these companies like, I don't know, GitHub, Spotify, SoundCloud, we release and deploy our actual website, our back-end systems, hundreds, thousands of times a day. It's very easy. And we should be able to do the same thing on mobile. It doesn't matter if you can't release to the App Store, you should be treating your internal alphas in exactly this way. You should always make sure that you are pushing code directly and make sure that you fail early. The other thing is create a process that suits you. So that's what I meant earlier at the beginning of the talk. So today you'll have heard Facebook built React Native because for them it makes a lot of sense. Spotify have a big system of tribes and all these different tools. We've built a feature team system, all these different ways, and you should always think about them all, but build your own process. At the end of the day, what works for you is probably slightly different to what works for somebody else. So yeah, my other colleagues from the team are here today and tomorrow, so feel free to come and chat to us about anything that you want. And that's all I have to say. So, thank you.
Okay, guys, who has any questions? Well, nobody? Okay. So, thank you, Michael.